All right, and we're live. Welcome, welcome. Oh, that's on the wrong side. Okay, here we go. Hopefully everything's good. It's been a minute since I have streamed, but that's okay. Okay, let's just make sure we're good. All right, so today, due to popular demand, I'm going to be doing the C streams publicly. So that is our plan. We're going to be working through Programming in C 4th edition by Stephen Kochan. Yo, let's go, Salty. Welcome, welcome back. It took 5-6 days off, but we're good. I think it was 5 days, but no, we're back and better than ever. So nothing really is gonna change with the streams. I think the only thing is I'll just be engaging less in kind of the AI stuff. So good to see you. Appreciate that. Hello, Vanor. Welcome, welcome. Yeah. So no, it's good to be back. I've been missing it. It's nice to be back for sure. So yeah, we're gonna get right into it, I guess. Really. So the last time that we were doing this, we were midway through chapter 3, which was on variables, types, and expressions. So we're on type specifiers. So kind of like long, short, and this is like number of bytes, I think. Well, these are number of bytes here, and then unsigned or signed is important, obviously. So yeah, I don't know. We're just gonna kind of. I don't really know how I'm gonna do the C streams. I'm just still kind of like learning, but we're gonna, I think, kind of read through the textbook, take notes, and then I've also got the terminal open, with Vim ready to go, so that we can write some C programs. So the usual, yeah, and as you probably saw from the previous VOD. At the end of the chapters, there's exercises that we work through as well. Where are they? Yeah, here. So there's a bunch of exercises to do. We are so back. Yes, indeed. Nice to see you, Juan. Honestly, these streams make me want to start my own, but instead of web dev or other software engineering things, do self-hosting and home lab. Yeah, you should, Vanor. That'd be really awesome, and I think that would take really well. Dude, I got recommended this and I have an exam to study for, or this stream. And I have an exam on Monday. Well, I hope it's helpful. We're doing the basics, Tezzy, so I hope it's helpful for you. I'm not sure if it will be, but you can stick around and ask questions and stuff. Yeah, the length is kind of not specified. Along as 8 bytes on Linux, but 4 bytes on Windows. Yeah, I think a long is 8 bytes. Well, we'll find out. Once you got moved into your apartment soon, yeah, Vanor. I know how it's like to move, my friend. I moved a few months ago. Now C, yeah, we're just doing C for now. HMU. There's gonna be a web dev stream on either. It's probably gonna be Wednesday, but I might move it to tomorrow. We're doing the web dev's not dead. We're just varying it up. We're just doing some different content sprinkled in. I want to do at least one C stream a week going forward. So that's kind of the plan. But anyway, so let's get started. So if a specifier long is placed directly before the int, the declared integer variable is of extended range. So, okay, so then on many systems, an int and a long int have the same range and can either be used to store integer values up to 32 bits, or if it's signed, it's 2 to the 31, right? I think its default is signed, right? As with floats and doubles, this particular accuracy of a long variable depends on your particular computer system. Yeah. I think that's fair. Which is kind of annoying, but it is what it is. You did an internship. Everyone uses AI these days. No one writes code by hand. Char and long are all signed. Yeah. I thought that was their default, right? A constant value of type longint is formed by optionally appending the letter L onto the end of the integer constant. Oh, I didn't even know this was a thing. So can I like control click this? Hello. I guess maybe I can't. I don't know. It's not. Yo, blueberries, what's up? What's up? Do you not feel overwhelmed when you're taking on many things at once instead of focusing all your efforts into one or two things? Not too much, Danny. Was wondering if you'd be live. Yep. I took like 5 days off, blueberries, kind of to take a bit of a break, but I'm back now and doing C and stuff. But no, I think the trick, Danny, is to just kind of like take it one stream at a time, right? I don't really think about the future that much, like long in the future. I just kind of take it one stream at a time and continue with the momentum and try my best. But no, I did have a long day at work today. I'm on site this week, so it's actually been even busier than normal. So no work from home for me today. I put in 8 hours, got home, ate dinner, and then now I'm on the stream. So I'm in office, I should say, today, tomorrow, Wednesday, and then I'm on vacation. But yeah, we usually do little office. We usually do quarterly meetings in person. Anyway, okay, so nice, man. I started learning low level stuff after going crazy with my front end. Yeah, nice, man. Yeah, it's cool. I did some of this in school, but it's going to be good to kind of refresh, right? So let's do so we've got like a long, which a long accuracy or length in bytes depends on the host system, but is usually I think it's 4 bytes, right? So can hold signed or can hold 32-bit value or whatever, right? And then I guess I'll just like make this like this. Can also form constants by appending the letter L to the end of the constant. I want to write that down because I feel like that's something that's kind of neat. But anyway, I have Python on my screen for the first time in a while doing a refresher. Nice, blueberries. That's awesome. You should probably never use long int or long int. Looking at minimum 4 bytes, but realistically it's 8 bytes. Oh, yeah, that's true. No, that's fair. And I think it's just kind of good to be aware of it, right? Yeah, so this is kind of a neat way of handling it here. So it's kind of cool. I did not know that was a thing. Okay, so you can use long int. The letter L is used as the modifier. This means that the format characters li can be used to display the value of a long int. LO can be an octal format. Why would you ever? I don't know. I guess you could have a long octal. That'd be kind of weird though. And then long int. Yeah. So then long. Usually 64 bits. So 8 bytes. Oh, it's guaranteed actually. That's cool. The long specifier is also allowed in front of a double. So, okay, so that's good to know. And that probably just changes the size of the mantissa and the exponent, I would imagine. Right? When you're doing the floating point encodings. Okay, so the display along double, the capital L modifier is used. Okay, cool. Displays along double in floating point notation. LE displays the same value in scientific, and then LG chooses between the two depending on the precision of the double. Is this your new focus, or are you still doing the Google Drive clone? No, I'm still doing the Google Drive clone. The stream for that will be either tomorrow or Wednesday. I'm doing kind of both. Just because, again, I think it's good to have variety content. I don't know if like the C stuff is gonna be super popular or what, but I know there's a subset of my community that really digs the lower level stuff. So, you know, in spirit of that, I kind of want to, and also I find it interesting too. Yo, how's it going, SB? Welcome, welcome. Specifier short tells C, the compiler, that the particular variable being declared is used to store is very small, fairly small. So I think what's short? Yeah, short is not less than 16 bits. So that's good to know. I don't know if there's like an easy way to highlight with this because I don't want to have this menu always open. But yeah. Lower level is cool. Yeah, it's definitely cool. Yo, how's it going, Joseph? It's always good to expand one's horizon. I agree. What's the book I'm using? You can see at the top of the description, but it's Programming in C 4th edition by Stephen H. Kochan. But you can see the references in the top of the description. There's no way to explicitly write a constant of type short int in C. To display a short int variable, place the letter H in front of any normal integer conversion. Okay, so that's the what do I call it? Placeholder uses placeholder L for, or it's lowercase L. What's the difference between the lowercase L and the uppercase? Oh, lowercase L for ints, or uppercase L for, whoops, for doubles. I guess that's fine. And then we've got our short. Minimum 2 or 16 bits. I cannot type today, guys. 2 bytes, and then uses placeholder H as well. And then you can, add the integer, octal, or hexadecimal in front as well. And then the final specifier that can be placed in front of an int variable is unsigned. Yo, Anthony, how's it going? What's the reason for learning C? For fun. And to kind of expand my understanding of low level, just because I think it's a good, it's good to know. Am I currently employed as a developer? I work in IT. What's your goal from reading this book? Like for me, I learned how to program in C, and I do it to learn how to make malware and hack devices. My goal is just to learn and to understand and kind of to have fun. But also, like, I think it's cool to be able to learn, a low-level language. It gives you an appreciation for programming and technology in general. Like just knowing how shit works at a low level, like how programs run, and even you get some appreciation for even like how these things translate into assembly and stuff like that, because C is so close. At least in a lot of these trivial examples, it's very close to the assembly. In the sense that like a C instruction, it's pretty easy to be broken down. I don't know. I've seen C versus assembly comparisons. I don't know. I think it's just good. Assembly sucks to learn. Yeah. And it opens a lot of doors too, because I think like just understanding, having a higher, like more depth with the software you work in is important. Like you can do web dev all day. Like I do web dev, so I'm not even, I'm not gonna. But this gives you a better appreciation for computers than web dev could, for example. Yo, how's it going, Newton Ave? Nice to see you. Let's subscribe. I love how much you love low level. Yeah, no, it's good. I also love learning, Joseph. I also love learning. So I took it, then I used a lot of computer architecture, but I don't think I'm going to revisit it. That's fair. That's valid. And I mean, I'm doing this because I just for fun, and also I think, it'll be good if there's people out there that want to kind of also learn C and be inspired to do these things, then I can hopefully be a source of inspiration as well. So yeah. All right. So the final specifier that can be placed in front of an int variable is used, will only be used to store positive numbers. This makes sense because it's unsigned, right? So an unsigned int constant is formed by placing the letter U after a constant. So that's actually good to know. As well. So unsigned can be formed by keyword, or can be declared. or by placing the letter U when writing. My typing is abysmal today. And L. Oh, so L would be for the long, right? So, like, for instance, you can do, the example is 20,000 UL, or, you know, 0x00FF U. All unsigned. Cool. I find being able to read and interpret compiler output very valuable. Yeah, exactly. No. That's true too. Is it? Yeah. It's a language that's very much, you know, in this, like, how do I explain this? At least with these trivial examples, it's very easy to see how the C can be can be compiled into assembly and how it's actually working at a low level. Even though it's a high level language, it's still like, you know, you can follow a C program and you know, kind of based on its structure, see actually what's happening, how the computer is running and parsing that code. At least in the more trivial examples that I've seen, as kind of like comparisons. Ben Eater is one I actually watched recently. Also, I rewatched it in preparation for these streams. But Ben Eater is a creator that kind of builds like breadboard computers and different computer parts, and he walked through a C versus assembly, x86 assembly comparison, which I thought was really cool. C is great at abstracting away assembly just enough, but not so much so you can't reason about what's happening. Exactly. So an integer constant that's not followed by any of the letters that is too large to fit in a normal size int is treated as an unsigned int by the compiler. Interesting. If it's too small to fit in an unsigned int, the compiler treats it as a long int. Still can't fit inside long int. Compiler makes it an unsigned long. Okay, so there's a bunch of rules for this. So if you don't specify exactly how you're encoding the integer, it kind of, you know, the compiler kind of takes liberties, or not liberties, but it kind of has these rules to specify the encoding of the integer for you, I would assume. So when declaring variables to be of type long int, short int, or unsigned int, you can omit the keyword int. Interesting. So that's another cool tidbit as well. So when declaring integers with any of the modifiers, you can omit int, and the compiler will assume the type int for the variable. So like unsigned counter, or you know, long bit, I don't know, what do I call this, var1, etc. Right? You can also declare char variables to be unsigned. The signed qualifier can be used to explicitly tell the compiler that a particular variable is a signed quality. Its use is primarily in front of the char declaration. Interesting. So why would you make a signed? Why would a char be signed? Can you have like negative chars? I don't know about that. Further discussion is deferred until chapter 13. Okay, so that we can wait till chapter 13, I guess, to have that question answered. But that's okay. Don't worry though if the discussions seem a bit esoteric. Yeah, that's fine. So then here's our little cheat sheet, which will tell us like the types, constant examples, and the printf characters, which is nice. So this is a cool little table to have. I appreciate that, Derive. Thank you so much. Means a lot. All right, so let's do some working with variables. All right. So I'm just kind of doing like subsections for each part here. So early computer programmers had the onerous task of having to write their programs in the binary language of the machine they were programming. Yeah, that is crazy. Can you imagine, like, not even assembly, like straight up like remembering, the add or the load A command is 01100 or whatever it is, right? Whatever binary number it is. Like, and then you have to have like this printed out. You're basically, the human is the assembler. Like, that's wild. You know. Like, again, if you've ever seen Ben Eater before, Ben Eater does he made a 6502 8-bit breadboard computer, and he programmed, I think it was a Fibonacci app, or not an app. Calling it an app is crazy. It was a program that computed the Fibonacci sequence, and he programmed it on dip switches. So he didn't put the instruction with dip switches, and then there was like a increment to store it to ROM or whatever it was, or RAM even, and then he'd execute the program. That is like wild. He is ridiculously smart. Yeah, absolutely. Yo, how's it going, Watt? Welcome, welcome. Shit was wild in the age of punch cards. Yeah, exactly. This meant that computer instructions had to be hand-coded into binary numbers by the programmer before they could be entered in the machine. Yeah, this was like 1950s-ish. Love watching those videos. Yeah, me too, man. I honestly, I discovered Ben Eater like 10 years ago. I was like, 15, 16? And I actually remember specifically, I was on a family vacation, and I remember like finding his videos and like going down the rabbit hole. But by that point, I already decided I wanted to be I thought I wanted to be a teacher, a biology teacher. But I still found those videos really interesting. What's the book name? The book name is Programming in C 4th Edition by Stephen Kochan. You can also find the full reference in the description, or the full name written out. I should have a command for that, actually. I'm going to do that on the break. Furthermore, the programmer had to explicitly assign and reference storage locations. Yeah, so there was no virtual memory or anything like this, right? So today, programming languages allow you to concentrate more on solving the particular problem with symbols, variable names, right? So a variable name obviously can be chosen to be meaningful to reflect the type of value that is to be stored, right? So we obviously know about variables. This is pretty, if you've been watching the channel, you know about that. So for example, use the variable sum to store the result of the addition of two integers. Yes, of course. Hi again. Have you already code something down, or are you only reading by now? Yeah, I'm just going through the book, but I will get to the exercises at the end of the book, and I'll also program some examples too. Like when we get down to this part, I'll do some examples when we get a little bit further. But we're gonna do both at Davi, so that's kind of the plan. And this is also to watch. The idea behind these streams is not only for me to learn, but also so that, like, if you want to learn along with me. And take a stab at learning C in the great year of 2026, then you can do it. It's kind of like a study along sort of thing. So that's kind of the goal of this stream, right? This series, and I hope it'll be that, right? And we're gonna work our way. Our first goal is to work our way through this book, which I think we could do in a couple months, maybe. I don't know how often I'm gonna do the C streams, but we'll see. I'm gonna do at least one, if not two a week, I think. So yeah. Variables can be used to store floating point numbers, characters. Yes, we already know this. The rules for forming a variable names are quite simple. They must begin with a letter or underscore and can be followed by any combination of letters, underscores, or the digits. So variables in C must begin with or a letter and can contain any number of letters, numbers, or underscores. Cool. The dreaded pointer. Yeah, we're not. I don't think we're at pointers yet. It's coming. Following variable names are not valid. You can't have spaces, you can't start with a number, and you can't have a reserved keyword. As long as the variable name is not a reserved keyword. Like, so you can't do, you know, if, for, int, etc., right? Yes. In general, any name that has a special significance to the C compiler cannot be used, obviously. You should always remember that the upper and lower case letters are distinct. Yeah, so variable names are also case sensitive, I think, right? Yes. Your variable names can be as long as you want, although the first 63 characters might be significant. Can be as long as you want, but usually only the first 63 or 31 characters are significant. Yeah, so that's kind of crazy. Believe me, you won't find it fun when you actually start coding. I've done some C in my past, Abby, so I already have a bit of chicken Alfredo secured. Nice, man. That's awesome. When deciding on the choice of a variable name, keep it one recommendation in mind. Don't be lazy. Pick names that reflect the intended use of the variable, as we've been doing. And you know, if you've been watching the streams, you know I'm not the best at picking variable names. But you know, it's a skill, definitely, right? So yeah. Just as with comments, meaningful variable names can dramatically increase the readability. Of course they can. All right, so arithmetic expressions. There we go. Let's take our first 5-minute break. User says, it is fun. Of course you'll struggle. You'll actually struggle with any language, and that's where the fun is. Exactly. Totally agree. M dash, clearly AI slop. Wait, where was the M dash? Oh, here? Yes, indeed. The book that was written in 2014 is AI slop, or it might be 2015. But yes, this is very basic, and I will say the next few C streams are going to be very, very, very rudimentary, basic C. But that's good because, again, you know, if you want to follow along, we're starting right from the beginning. You know, fill in all the gaps, and kind of have that completed experience, right? So, yeah, that's kind of the goal. So yeah. But no, you know, the AI was trained off of books like this that have the M dash or whatever, and then it picked up on that pattern, right? So, you know, there's a lot of shit that was stolen to train these models, right? So, anyway. In C, I don't think I can say the same. Fair enough, Davi. Here's a good question. Why do we need the type with the variable? I think, correct me if I'm wrong, but the type, well, the type is for how the data in the variable should be interpreted by the compiler, no? Because if you have a, it's all numbers, right? So if you have a character, that's different because then it tells the compiler that you should use like ASCII or Unicode or whatever to reference a character, versus like if it's an integer, it's just a number, versus if it's a float, it should read the data as like, you know, having that kind of mantissa exponent encoding. Like it basically is like how the bits should be interpreted, right? I think that's like my understanding, at least. That's the type, the reasoning for the type. Yeah. And then obviously the modifiers for like the length, right? Or signed or unsigned. The essence behind static typing, yeah. And also the thing is too, is it's good because two reasons. Why is static typing good? One, because it allows you to visually debug your code and keep track of what types are what. And B, it's faster for the compiler because then the compiler doesn't have to infer types. So compiler needs to know the size to allocate enough memory to the stack. Yeah, exactly. Exactly. Yeah, because if it's 2 bytes versus 8, you know, that's different. So yeah. I don't know. It's good stuff. So I feel like this is pretty basic here. This is just like precedence of, this is like order of operations. Yeah, no, C is good user. I've used it. I used it in school for a bit. So like I wouldn't say I'm good at C, but like I have a beginner level exposure to C. Like I used it for a class, so I probably know up to maybe a third of this book. I don't know. We'll find out, I guess. But yeah. Oh yeah, I was gonna add that command. Who wrote this book? Stephen Kochan. Here, speaking of that, I'm gonna do that right now. I'm gonna add a, what was it, Nightbot. I'm gonna add a Nightbot command for the book. Running programming in C. I'm just doing this on my other screen here. I need the reference. Oh, Stephen G. Kochan, that's what it is. Okay, so this is, I need the reference. Yeah, so I'm going to say programming C 4th edition by Stephen G. Kochan. There we go. Cool. Yep. I am already on it. So now you can do cbook, and there you go. I'm not going to give, what do you think of this book? I think it's good. And I chose it specifically, user, because it's a little bit newer. It was released, I think, in 2014 or 2015. So, and I'm not going to tell you where to get the book, because if I did, that would be illegal, but you can find it. It's out there. So, you can also pay for it, but I mean, you know, yeah, I'm not gonna say. So okay, working with yeah, that shit got shut down. I think Samurai. I'm pretty sure. I thought you were doing Odin Project. I still am, Obi-Wan. I still am. This is just a side quest. We're just varying the content. I'm still doing both. You pirate your books, yeah. Yeah. That's yeah. It is a side quest, and also because a sizable portion of my audience enjoys the lower level stuff. So, no, exactly. I don't find C for fun or for personally taste. I've a ton of languages, but Python, like Rust, C++, Go. I just don't like the malloc and free stuff. Yeah, fair enough, Debbie. Yeah, we stupid? Nah, you're not stupid. But no, I just think it's fun. So okay, so this is basically, if you've taken what grade did we learn this in? Like grade 6 maybe? So like what, 12 years old? Order of operations, right? Or it depends what country you grew up in, obviously. So obviously, bed mass, that's what we used. So we have brackets, exponents, division, multiplication, addition, subtraction. So obviously, plus and the minus, comes after, is not as prioritized as the multiplication and division, right? So earlier than that, third grade, I believe, in my country. Yeah, I want to say like it was grade 5 or grade 6. I don't know. Something like that. 10 years old, 11 years old, something like that. It's like 80 pounds for a book, yeah. It depends on the book, innovation. You can find like used textbooks for like, at least here, like I could find a used one for like $40 or $50 Canadian, which is what, like $40 USD, 30 to 40 USD. If they're used. If they're new, it's like, yeah, like 100 some. But like used books you can usually find for cheaper. However, the problem with the used books is they're usually older. But like if you're getting a brand new like bleeding edge textbook that like came out within the last couple of years, you're right. You'll be hard pressed to find it used. Library plus copier, yeah. We had a kid in our high school that printed out an entire textbook. He like photocopied an entire textbook and charged the school like however much money in ink. It was like over $100 because they had to replace the ink. I remember that was a big thing. All right, so then obviously, let's code along with this example anyway. So I forget like what folders I have in here. So this is the okay. So we have the CD programs, and then we'll do a new one. So we have our programs in here. So we'll do Vim arithmetic. .c. So, better learn from a video course or a book. The book you're studying from is 180 euro. Damn, that's like 300 Canadian dollars probably. That's crazy. Or like 270, 300, something like that. All right, and also, as a side quest to learning C, we're also using Vim, which I have very limited experience with Vim. I got you. But yeah, we're gonna do some Vim stuff too. I remember I tried learning C or C++ or something when I was like 12. Yeah, it's difficult, especially when you're that age. I probably couldn't do it at 12 either, to be honest with you. So we're gonna like make this program, but we're gonna make it like a kind of our own, right? So we're gonna kind of do it, our way. So we can define some values. So we can say like n1 is equal to, I don't know, let's just say like 300. Have I tried out ZIDE? Yes, I have. I'm not a huge fan of it. It's probably just because I'm not good at, I don't know. I found it's fast and I like it, but it doesn't have enough features for me. But that's maybe, it's not, I'm not blaming Zed. I'm blaming me as a user. Wild man. The book you're using is 30 pounds. Yeah, that makes sense, SB, because it's older. Yeah, that's true innovation, yeah. Let's say 3, int n3 is equal to just another random, let's do 74, and then we'll say is equal to, I don't know, 6,700 for no particular reason. Okay, so, and then we can declare our result, of course. I like Zed when I want a minimalistic editor. VS Code for more feature rich. Yeah, Codex, that's fair. Yeah. I'm just using Vim because it's fun for C stuff. But but I wouldn't use it to make any serious stuff. Zed is awesome was my daily driver before Envim. Yeah, and the thing with Zed, I have nothing against Zed. I just was bad at it. There's a German version of C, which is a nightmare. Yeah. All right, so let's say results or res is equal to, you know, we can obviously do our precedence rules. So we can say like A plus B minus C. Precedence. So before addition, subtraction, obviously. We could say, you know, A plus B minus C is equal to whatever that value is, which is the result. And then we can just do res is equal to, we can even do C, because I guess this would be, you know, A times C plus B times D, precedence, and then printf. I mean, this is pretty trivial, right? We obviously can't divide because, well, I mean, we can, but it's not going to give us a float, right? So if we do like a, you know, so if we do an integer division, or not A, it's not A, B, C, it's N1. I am very silly. I got to study an hour when wife comes home, so I'm gonna lurk and game until then. Awesome, Codex. Appreciate that. Okay. I forgot that I named them N1, N2, N3, N4, but that's okay. Okay. So we'll just change these up. We also accept input too, but that, you know, that's whatever. You know how it goes. Yeah, absolutely. I do. And then we'll say, let's do like a integer division. So we'll say N1 divided by N2, which should be int division, or like int division with no remainder. So that would just be printf, you know, N1 divided by N2 is equal to, this should be 100, right? So, and then we've got like, you know, we could do like a not perfect division. Like, I don't think 74 divides into 3, does it? Perfectly? I don't think so. But either way, we could do 300 divided by 74 or something. So res like N1 divided by N3, int division with possible remainder, or with remainder. I don't actually know how to get the remainder from that though. Like when you do that, because this will be like, so if you say did 300 divided by 74, that's going to give you like, what's the closest thing to that? Like 70, like it'd be like be 3 and then, I'm like slow. It'd be 3 or 4. No, it would be 3 and then some, I think. Whoops. There we go. And then we'll do a return 0 as well. Something fun you could do here, look at how division truncates and how mixing signed and unsigned changes the results. Yeah, we could do that too. So we could even do that. So we could do like, so we could do signed, or let's do int signed. Signed int, or signed number is equal to, how do we actually look? Can you can print it out as binary now? But yeah, so we can do like, well, actually, we can just do unsigned. We'll do like, I don't know, whatever number, 96. Yo, how's it going, Jay? Use bit shifts. Oh, okay. So that would be a left shift 31. So that would give you what? Like, that would give you the max number, though, wouldn't it? Okay, so you could do like one. We haven't technically gotten to that yet. So that would be something like this. Is binary like B? Maybe. It could be. I mean, I could always do hexadecimal too. That's like not too bad. Printf binary. Let's see. It is. Oh, that's a pain in the ass. Yeah, because there's no B. Yeah, both works, yeah. So I think, I mean, we could even print this as a hexadecimal, right? So this would just be all a bunch of Fs. Or it would be F, not F, sorry, it would be 1, 0, 0, 0, 0, 0. If it would be a bunch of Fs if I did one, if I did like then -1 or something like that, right? Then it would be a bunch of Fs. But we'll find out. And then we can play with it. So GCC, and then it was what? Data type, or not data types, arithmetic. .c, and then output, arithmetic. Overflow expression. Oh, because it's unsigned. 2,147,000, 2 billion with type int. Huh. Okay, so you can't subtract 1 off of that. Yo, how's it going, K10? Welcome, welcome. By the way, in vanilla NVim, I'm not using NVim, FJ. You got a binary out, it's just a warning? Oh. I see, okay. So then I could just, because it's close to the bound, right? It's because it's close to the bound. Yeah, so 7F. Okay, so that's kind of what I thought would happen. Maybe. Why is there 7? Oh, because it's 1. So if I went back into this again, it's because there's 1 bit that's a 0. So it's 0, 1, 1, 1, 1, 1, 1, 1, 1, 1, right? So if I go here and I did 1 shift 32 -1, that would be the bound. That would be the bound. So if I recompiled that, then I ran it. There. Oh no, I guess it didn't. Did it not like that? Oh, because did I save it? I thought I saved it. What the fuck? Oh, because I didn't change the expression. Dumb. That's why. Okay, so does this still work? I don't know. We'll find out. Oh, it overflowed. Okay. Fun. You sounded like Siri, fair. Is undefined behavior. You can't shift 32. 31 puts the bit on the most significant bit position. Oh, okay, I got you. I wasn't sure. Because I know this is technically the bound, right? 2 to the power 32 -1. Or 2 to the power 32. Okay, that's fair enough. Okay, well, whatever. It's fine. We got a thing. C is amazing. Appreciate you, Pato. Okay, so that's cool. What was the actual output of that again? Oh wait, I didn't recompile it. That's my bad. Okay, so it's going to be fine. So yeah, so obviously here you've got, you know, right order of operations. Oh, n1 divided by n3 is 4. Okay, so then there is a remainder on that, I would assume, because 300... Would 300 divided by 4 be, like... I don't know, I can't math today. That would be like 75. I guess that's close. But anyway. Okay, so let's go back to it. Is there anything we really missed with this? Okay, so we declared the integer variables, blah, blah, blah. The result is subtracting b from a. Okay, this is pretty simple. The next statement has the effect of multiplying the value of b by the value of c. Okay, this is trivial. Okay, so this is kind of like walking through all the arithmetic, right? On some computer systems, attempting to divide a number by 0 results in abnormal termination. Right, which I think we would get a compiler error, right? Like, so if we tried to divide by 0, for example, like what happens here? Let's just do n1 divided by 0. The compiler is going to catch this, right? Yeah, so it says division by 0 is undefined, yeah. So that makes sense, of course, right? So that's fine. Rather, the result is display the corresponding... The expression a plus b times c does not produce the result of 2550. Rather, the result is displayed by the corresponding printf statement short as 150. This is because C, like most programming languages, has rules for the order of evaluating the terms. Yes, of course. Yeah, so that makes sense. Yeah, over the operations. And then exponents have even more precedence over that. If you used B, it would have worked, would it? Is that right? Or not Vim, sorry, whoops. No, it just printed B. Okay, let's see what innovation said. Just for clarification, 1 bit shift left 31 gives you T min, lowest possible value for assigned integer. Subtracting 1 underflows it. Oh! I was assuming it was shifting the wrong direction. Yeah. Okay, so then if I wanted to go the other way, then I would flip the arrows, right? The bit shift arrows. Okay. Yeah. So if I go to this, so 1 shift left 31 by itself. So let's just do that by itself, right? So if we do that by itself, is this negative? It should be. Let's compile it. And notice we don't get an error this time. Oh wait, I need to fix the print statement. We need to go back to, let's go back to hex. Yeah, so we're getting 8 and then all zeros, right? So that would be 1 and then followed by, 32 zeros or whatever, right? So this is hexadecimal, right? So yeah, I should also probably I think if I print it as a capital X, I think it'll print the 0x in front of it. I'm pretty sure. Oh no, is it not? How did I... Where were my notes for that? Let me just... Where was that? Integer type. Placeholder in front. Oh, with the hashtag. Sorry. With the hash. I need to put in the hash. So it's this. This is what I was looking for. Hash X. Like this. Yes, now it's 0x. That's better clarification. Print decimal with D, it should be negative. Yeah, we can do that as well. So let's print the decimal. Yeah, negative 2 billion, 147 million. Yep. You are right. Very cool. And then so we underflow. So as we mentioned, if we underflow this by subtracting 1, as innovation mentioned, then it'll flip to positive, right? There it is. So now it's positive, right? Hello from Japan. Did you finish building the Google Drive clone? I have not yet, Nini, but I am getting there. I'm just doing a little side quest, but I'm almost done. I'd say a couple more weeks, but I appreciate you joining. It's nice to see you. The hex bit I'm doing. So the hex bit, that little thing was just to show the hexadecimal Obi-Wan instead of a decimal. So the hashtag was to have that little 0x prefix. So when you do hashtag or at hashtag X as the placeholder for the printf, then it shows the little 0x, like the leading 0x. That's what that's for. Here's a bonus if you feel like it. What happens if you take the number and negate it? Well, let's find out. So let's negate that. So if we but if you put a negative sign when declaring an unsigned num, that doesn't do anything, does it? Like, what does that do? Like, you can't do this, surely. Or maybe you can. I don't know. Like, does that break because it's unsigned? Like, I don't think the compiler will like that. No, you can't do that. Or maybe you can. I don't know. Oh, okay. Yeah, you need brackets on it. Yeah, that's fair. No, for sure. Oh, no, but I already had that. I should also add that to this, too. But I don't, like, it seemed to compile. And it's still positive. Maybe it doesn't matter. Maybe it ignores it. Does it ignore it? Is that the trick? The trick might be that it ignores it. I don't know. I'm guessing. Based on that behavior. Oh, I want to show the negation of tmin is tmin because there's no positive equivalent. Oh, I see. Okay. Okay. But I thought because it's unsigned that, like, what would be the point if you're declaring an unsigned? Oh, I didn't even fucking stupid. I didn't even put the fucking unsigned there. So that's my bad. But does that even change anything? No. Not Vim. That's what I want here. Anyway, I don't know. But I didn't think, like, putting a sign in front of an unsigned integer is probably meaningless, right? Surely. But anyway. All right, let's take another 5-minute break. I'm going to be right back. I'm just going to close my window and turn on my air conditioning. So I'll be back in, like, quite literally a minute, so don't go anywhere. Oh, wait, I don't have my be right back text. Weird. Okay, well, I'll be right back in 1 sec. All right, no, we're back. It was just 2 seconds. Yeah, I don't know. I don't have it on this view because I needed to recreate my. I needed to recreate my view because I'm using a 1080p monitor in this location. Unsigned didn't change anything because the operations and the bit pattern was the same. Oh. Fair enough. Yeah, no, innovation's goated. So, Yeah, no. And again, I don't know. I'm also looking at C for the first time in like, what, like 2 years ish. I mean, besides the first stream I did. But yeah. Anyway, I hope everyone's having a good Monday evening or Tuesday morning / afternoon, wherever you are. I think the important lesson here is that the sign unsigned is only concerned with the interpolation of bits. Never changes any bits. Ah, okay, yeah. I see what you mean. I see what you mean. For me, Obi-Wan specifically, why am I streaming? Yeah, it's mostly to hold myself accountable. But now I've kind of like built a community, and I kind of like feel like streaming is not only helps me out, but it also helps all you out in some sense. And I think we all get kind of enjoyment out of these streams, and I do like want to continue to learn programming just out of interest mostly, and also just to build stuff, which is hence the web dev stuff. But that's exactly it. Jay, nailed it. That's kind of the idea. Just kind of build a community of, people that are passionate about learning and technology. Especially in this day and age, which, that's not a conversation I'm going to get into again. But, you can infer. So, but yeah, I think I don't know. I think that everyone has different reasons. Yeah, and the initial, well, certainly the beginning Obi-Wan was was to hold myself accountable, right? Because I wanted a way to learn. I wanted to learn, but I knew I wouldn't have enough motivation just myself to do it. So I wanted to stream it as almost like a public journal. Yeah, exactly. Well, and you could also have multiple things too. Like I kind of this is kind of something like, and I'm not going to claim I'm teaching, but like I've always kind of had a drive to not teach necessarily, but I kind of like to showcase what I do and walk through things. So I mean, like I wanted to be a teacher initially. So I mean, not that I am one. I'm not going to claim I'm a teacher, but it's kind of in a similar vein, right? It's kind of like a collaborative learning. I appreciate that, Matt. I'm slacking off too. I haven't studied today at all. Now it's actually time for bed. Yeah, that's fair. I mean, that's why I stream. No, I think yeah, in innovation kind of, nailed it with that too. I think there's a lot of anxiety in the space right now, and a lot of uncertainty and a lot of grifts, and that's just not what I'm about, Yeah, and again, like it's not a race, right? How do you find C so far? I like it, Matt. I have some exposure to it from school, but it's good stuff. I really like how bare bones it is and minimalistic. How do you implement good practices in your project without the use of AI? I understand the use of FGETs instead of scanf. Fair enough, Poods. I mean, again, I just don't. I just learn by doing. I learn by doing, and I read documentation, and I also get help from chat as well. So I feel like I kind of pick these things up as I go, kind of the old-fashioned way, so to speak. A lot of grief, a lot of resentment. Yeah, exactly. Well, if you go back one stream, the VOD from day one, Obi-Wan, is public, so you can watch that too. Your Arab wear? Nice. Yeah, I think you joined at a good time. This is still very, very early. This is still very early stuff, right? So, integer arithmetic with the unary minus operator. So this is kind of negating a number, right? So like if we negate a number, so if we say something like we'll do int negative n1 or whatever is equal to negative n1, and then printf negative n1 is equal to right. So that just negates it. Should be fairly straightforward. Yeah. Yo, how's it going, Amir? Honestly, I'm just using mindlessly checking comments, and then I might see a stream. The other times I joined was in study breaks. I just enjoy the interacting, trying to figure out what you're doing. Yeah, no, that's kind of what it's about. Can you send me the PDF? Well, the title of the book, Amir, is this is the title of the book. But I won't share the PDF because it's a paid book. So you don't have to pay for it, but I'm not going to show you how to get it. It's out there though if you do some digging. So anyway, so extra blank spaces are inserted between int and the declaration of ABC. Indeed, to make first support statements align with the declaration. Yeah, so that's that's kind of standard as well. So it's pretty easy. You also might have noticed each program presented thus far has a blank space. This too is not required. Yeah, so this is very basic too. In general, you can add extra blank spaces just about anywhere that a single block space is allowed, right? So that kind of allows you to format your code such that you can read it better. So, and then this is kind of talking about precedence rules. So if we do something similar to, first printf call, where would this be? Yeah, here. So this would be something like, we could even do a res equals what? Like 6 plus n1 divided by 5. Well, let's do divided by 6 to make it 50. Times, well, actually, yeah, times what? N2. And we'll do printf is going to be, 6 plus, and I'm just doing this example right here just to illustrate. I'm not going to do all of them. But n1 divided by 6 plus, or times n2. So this should be what? And then res, right? So, okay, so n1 is 300 and n2 is 3. So then we do n1 divided by 6, which is 50 times 3, which is 150 plus 6. So the result should be 156, right? Perfect. So that's exactly what we get based on order of operations. Yeah, exactly. Hell shocked. Yeah, you're right. Yeah. C is like foundational. J. I think that still exists, Obi-Wan. I think that's still a thing. But anyway, so we obviously got that. So as you know, we do the n1 divided by 6 first, and n1 is 300. So we do 300 divided by 6, which is 50. N2 is 3, so 50 times 3 is 150 plus 6 is 156. There we go. So that's good. So the second printf statement introduces a new twist. You expect that dividing a by b, then multiplying by b will return the value of a, which has been set to 25, but this does not seem to be the case. Might seem like computer lost a bit somewhere along the way. The fact of the matter is the expression was validated using integer arithmetic. Okay, so this is an interesting case. So let's do this example. So if we did this example, so let's just do Let's make another smaller number. Or if we did, let's just do 3, or what is it, 25 divided by 2 times 2. And then printf 25 divided by, I'm just doing the example from the book here. So you'd expect that if we did this in the order, because multiplication and division are the same precedence, 25 divided by 2, an integer, that's what, 12 times 2 is 24. So you'd expect 24, right? Which I guess it is 24, because the integer lost that precision on the division. So that actually is right. Never mind. I'm silly. So that actually is 24. Because the 25 divided by 2 gives you 12.5, which can't be represented, so it's 12. So that's kind of what this is going to say here. Yeah. So you'll expect the dividing a by b, but this does not seem to be the case. If you glance back at the declarations, so they're both type int. Therefore, the value of a is divided by the value of b, or 25 is divided by 2. You get an intermediate result of 12, and not 12.5, because 12.5 is not an integer, obviously. And you lose that precision, right? Don't forget, if you divide 2 integers, you always get an integer result, which is actually nice that it doesn't like give you an error, right? So that's kind of nice. I mean, it can cause weird behaviors, because like then you might be losing precision somewhere that you don't expect, but yeah, web stuff is far removed from it. It's like an abstraction of an abstraction of an abstraction of an abstraction. I can't even speak today, guys. Yo, how's it going, Pretzel Pete? That's an awesome name, by the way. I like that name. So yeah, it also, yeah, it does feel good understanding stuff. I agree. All right, so the decision of whether to use a float variable or an int variable should be made based on the variable's intended use, obviously. So if you don't need any decimal places, use an integer variable, as it's more efficient, right? So this is kind of good. So we should probably write that down. So using integer versus floats depends on what the semantics of the variable, right? So if the variable will, what should I say? If the variable only needs to be an integer, i.e. you don't need decimal places, then use int, as it is much faster, right? However, if you need decimal places, use float or double, as that gives you precision with decimal points. However, not infinite precision, as we've discussed, because you have, for floats, you've got a mantissa and an exponent, and the mantissa and the exponent. The mantissa is like the part that you multiply with, or the base, so to speak. I think it's kind of like a base, isn't it? And then the exponent is or it's not the base, I guess, but it's the, so if you're using scientific notation, so if you did like, let me walk through, I'm going to think about an example to this. So like, let's say you have, let's do the number like 2.5. All right, so let's say your mantissa is, so you have a sign. So let's say, let's say for example, you have a sign of 1 bit. So first bit is sign. Next 4 bits are a mantissa. Last 3 bits are exponent. And now exponents can have signs as well, right? But let's just assume for sake of example that they don't. Then you have 2.5, which with this, specification would be, the sign is 0 since it's not negative, so it's positive. And then the 2 would be, so we have 4 bits, so 0, 0, 1, 0. And then the exponent in this case, or wait, no, what would this be? 2.5 times 10 to the, Or wait, how? Hold on, I'm misunderstanding this. Wait, hold on. Because the mantissa then has precision in it, right? So there's a invisible decimal place somewhere. Let me actually refresh this. The encoding is sign bit exponent field mantissa. Oh, is it exponent then mantissa? Oh, okay, I got the order wrong. Let's just say next 3 bits. Last 4 is mantissa. So we have like, so it would be like this. So it would be S, E, and then M, right? So something like this. Now, yeah, so I think the mantissa though, so if we did 2.5, the exponent is to the power 2, right? So I think it would be something like this, if I remember correctly. So let's say 2.5 is, so the sign's 0, the exponent would be 1, so 0, 0, 1, and then the mantissa would be 5.5, right? So it'd be 1, 0, 0, 0, I think. I think that's right. Something like this. Because it'd be 2 to the power 1, and then I don't know if that's quite right. It was something like that. Yeah, it's not right. I didn't think it was perfect. How does this, or would it be this? Because exponent has a bias. Right, no. I'm assuming that there's not, I'm assuming that there's no bias, just for sake of example. Because I know the bias accounts for negative exponents. So like if there is a bias, let's say that the bias was like 4, right? Then you'd have an exponent of 1 would be like this or something. Or no, it would be like this or something like that, right? Oh, you can't see the number because of the chat window? There you go. Sorry about that. You'd lead with a 1 in the mantissa field? Yeah, I thought so. So it'd be this. Two is 0, 1, 0. Is that with the bias though? The mantissa is implied to be 1. Yeah, that's what I thought. But if there is bias, it'd be something like this. But let's assume no bias. So this is. But would this not be an exponent of 2? So would this not be 2 to the power 2? So it's 4. Let me friggin' float 8-bit encoding. Let me just like see. Because I don't remember how this. This is going back to school now. The bias in this case is 2 to the power of bit field, so 3 minus 1, I believe, so 7. Right. Yeah. Yeah, that makes sense. Oh, so it is 1 decimal. Okay, so that is right. So then if we were to do 2.5, it would be this. So if we were to include the bias, then that would be this. This would be 2.5, I think. Right, because you have, so the bias, this would be an exponent of 1. Or no, sorry, this would be an exponent of 1. Sorry, my bad. This would be an exponent of 1. Assuming this, right? 3 minus, yeah, I think that's right. So the encoding right now is 2 to the power of -5 times the mantissa, which is 1.75. Yeah, I think, but if we include the bias, right? If we assume that the bias is like, so if we have all zeros, then that's negative 3, 2 to the power -3, I think, right? Because I'm using this example in this kind of image. 3 biased exponents digits, so, because 0, 1, 1 is 3, but that's 0. So then if we wanted to do the power of 1, we would do 4, right? And then 1.1, which would be, like if we assume a decimal point here, then that would be 1.1. So that'd be, I think, right? I don't know. Unless I'm losing my mind. Unless this is a 1 and then that needs to be a 2. I don't know. Shit's confusing, guys. Shit's confusing. But it's something like this. The bias is -7, but all the zeros because it's 1 minus 7 denormalized case with an mantissa leading with 0. Yeah, but is it the bias? The bias is... I thought the bias is just what you shift. Like, so for instance... okay. Yeah, but then don't you have to encode... Then how would you encode, like, 2 to the power of plus 6, then, in that case? Or could you even? I'm actually going to get rid of this. But yeah. I don't know. This is like going back to the CS days, guys. Mini float. Here we go. Yeah, so this is what I thought, right? So... Oh, no, that's not that. Never mind. That's not what I wanted. You have to have a 13 in the bit field for 2 to the power of 6. 13 minus 7. Oh, I see. Okay. Oh, so this one's actually... This one's actually 4 exponents. And I remember the example being the other way around. But I guess that's fine. We don't have enough bits for that. No, exactly. So I'm using 4 bits now for the exponent. So that's right. So the exponent's 4. You're right, Innovation. That's true. That's why I was confused, because I was only having 3. But if we did... So now... Okay, so if we did... If we did... 2 to the 1 minus 7. Yeah, so this is like... let's see. Yeah, so this example would be 0, 0, 0. Is there like a mini float calculator? Maybe. Let's find one. This might be what we need. Okay. Well, that's big. This is a big one. So there's no mini float. Okay, so let's see. Exponent is 4, mantissa's 3, and the bias is 7. Okay. So then if we do... So, okay, so this is what we want, I think, right? So if we do 1.0, so this is 1.0, right? Which would be, you know, 2 to the power of 0 times 1.000 base 2 is equal to 1.0, right? So something like that. Now, I was wrong for 3 exponent bias. The bias would be 2, so the power of 2 minus 1, so 3. Yeah, that's what I was on initially, Innovation. But that was for 3 exponent bits. I switched it. So now we're doing 4 exponent bits and 3 mantissa. So now, if we want to do our 2.5 example, our 2.5 example would be this: 2 to the power 1 So that's 2 to the power 1, and then we do 0. So what would that... I don't even know if 2.5 is actually representable. Is it? Oh, yeah, it is. Okay, so then we do 0, 1, 0. Oh, yeah, because you're doing... Right. Because you're doing 2 to the 1, which is 2, times 1.010, which is equal to 2 times 1.25, which is with base 10, which is 2.5, right? That's what you're doing. So you're doing 1.25. That's what this is. Yeah, it is 0, 1, 0. Yeah. So that's the 2.5 here, right? There you go. Yeah, I got it. Okay, now it makes sense. That makes sense. So let's do one more example. So if we want to do like, let's think of another example that would work. I'm just trying to think like off the top of my head like what we could do. Like, can we do? I think we should be able to do 12, right? So if we did 12, that would be 2 to the power. So let's think about this. So 12 is equal to 2 to the power of 3 times 1.5, right? Which is 8 times 1.5. Okay. Now, if we wanted to represent that, we could work backwards. So this is that. So it would be 8 times 1.5. Which is 2 to the power of 3 times 1.100 base 2, which is then, if we were to do this inside of our encoding, that would be 0, 1, 0, 1, 0, no, 1, 0, 1, 1, and then 1, 0, 0, like this, right? Well, no, you would, because you'd still need to multiply to get 12, right? You'd still need to have 1.5. So I think we should have 0, 1, 0, 1, 1, 1, 0, 0 for 12. Oh, sorry, 1, 0, 1, 0. Okay, so we were close. Was this because... Oh yeah, because that is 2 to the power 2, and then this would be 2 to the power 3. Right. That's right. Yeah. Because this is 2 to the power 1. Right. Yeah. So this is right, because this is 2 to the power 1. So yeah, it is 1, 0, 1, 0. Because what we're doing is we're multiplying 8 by 1.5, right? Anyway, there's just our little example. Now, if we had it the way we had it before, that would be then 2 to the power 4 times 1.5, which would be 16 times 1.5, which would be equal to what? 24, right? So this is this. Perfect. Okay? So there you go. So there's 24. So that's cool. So yeah, that's kind of a little bit of, there's a walkthrough of floating points. Learn MATLAB after C? Never. MATLAB. I've heard horror stories of MATLAB. Anyway, so there's our little mini float side tangent. So good. That was beyond what this book wanted us to worry about right now, but that's fine. A little side quest never hurts anybody, right? IEEE 754 bombs. Yeah, I'm also like derusting like crazy on this. Like, this is like an insane derust. Like, I did this stuff like 2 years ago. Like, I'm remembering now how this works. Okay. So, we already went through this, right? So, the unary minus operator has higher precedence, right? That's also true. So, unary minus has higher precedence over... is it any binary? Any other binary or any other arithmetic operation? Like, let's see, like C precedence charts. Yeah, so we've got this here, right? So we can go into if we open this in a new tab here. So here's our precedence, right? So we've got our urinary plus and minus. And then that's cool. This is more stuff. You know, there's more here than we included, but what's wrong with MATLAB? It's good for maths. Yeah, I don't know. I had friends in engineering and they didn't like it. Which rain sound do I use? I got you. Let me get the link actually right now. Just hold on. I should have a command for that, but there you go. That's the video I use. No, it's fake, Obi-Wan. It's not real. No, it's not. It's not. I put it on every stream. No worries, Bavia. No worries. Can you turn it off? Yeah, I could, but I usually like have it on just to fill the background noise. You know. My boat hatch open and the rain sounds made my pillow wet. Fair enough. Do you have like not a yacht, but like, do you have like a boat that you can sleep in? That's pretty cool. Floats are crazy? Yeah, it's crazy. What's the motivation for learning C? Just having a low-level programming under your belt? Yeah, pretty much. I also just, I don't know, I just find this stuff fun. It's good to learn, too, and to have that understanding. Interesting fact, the plus urinary prefix is pure dummy. Yeah, it definitely is. Because the plus urinary is inferred, right? Was the mini float a part of? Oh no. The mini float was just an example. I remember using the mini float. It's not a part of the C course XL, but I'm using it as an example because I recall doing this in school. The mini float is used for illustrating how floats work. However, imagine this, but extrapolated for like 32 bits instead of 8, right? Because obviously the precision here is not very high. Why can't I type for the life of me? It's, oh, you're all good. You're all good. Yes, little yada. I live and sail and code and work from it. Dude, that's fucking sick, man. That's awesome. You already know how to program. You're just learning the syntax. Yeah, but there's a lot more that goes into it. Variational. But yeah, nice to get back to it so quickly. I had a feeling you've done all this before. Yeah, no, I had. I've got the CS degree. So I did do this stuff. I'm just de-rusting on it. How do you get around verbose language when reading programming books or documentation? Reread it if I don't understand something. I'll also, like, if there's something I don't understand, if there's like a word that they use that I don't understand, I'll just Google it. C is a wonderful language because it makes the memory representation of data easy to visualize. I agree, Chris. So you're not a noob in programming? No, I'm not. I've been programming for about 3 years, Hogan. Your head perked up when you heard Rust? Yeah. D-Rust, yes. I'm also, I will say, and I don't know, because I know that it's popping tonight, is it? So the C streams are good then. I should do C streams more often. But what was I gonna say? I don't remember. I was gonna say. Oh yeah. English is my first language, so that helps as well. If English is not your first language, it can be certainly a lot more difficult. So I do respect that. 3 years professionally, absolutely not. No, 3 years total. I don't code professionally. People yearn for the low level power. Yes. I wonder if it's the C streams or the no AI tag. I don't know. I put the no AI tag as a disclaimer because I try to, I don't want to dissuade or sorry, I want to dissuade anyone that is about AI, because that's not what we're about here. So if you don't understand what you're reading, how do you even write it in plain English? Yeah, I mean, it depends, because I think you can, at least for me, like I can always understand part of it. Yeah, listen, I'm all about, guys, I need to make money somehow, so no AI is good bait. Best way to learn, tutorial practice or books? Any of that, Bhavya. That's all those are valid. Once you master C, you should learn about lifting the IR with LLVM, LMAO, and then you'll feel the pain of life. Fair enough, Michael. I yearn for the no AI coding streams again. Well, you've come to the right place, Hogan. Yeah, well, that's, you know what? That's the corner of the internet that I'm a part of, and so, you know, happy to have you. You know, so, and I'm not even, again, I'm not going to get into this much detail, but I'm not even anti-AI. I'm just anti-AI. I'm anti-AI for my endeavors, but I'm not anti-AI broadly speaking. That's all I'll say on that. Best way to learn doing a course, the basics, follow along, and do projects. Yeah, exactly. Yeah, I mean, the thing is too is everyone thinks that there is a formula to learning, and you must do it this certain way. There's so many different ways you can learn, guys. Like you can just you can read a book, you can do tutorials, you can do online courses, you can even just like program with your friends. You know, program alongside someone streaming like me. Like it's whatever works for you. Exactly. Did you finish the Google Drive project? Not yet, Freddie. Working on it still. I'm intermixing C streams with that. Works make me use Claude. It generally burns me out. It takes the fun out of it. Yeah, I feel you. My work uses Copilot. I work in IT, so it's a little different. But yeah, I feel you. No, the Google Drive project it's getting there. The back end's basically finished. Are all the major programming languages written in English? That's a good question, XLMR. I don't actually know the answer to that. No, that's fair, Obi-Wan. I'm just saying there are multiple different places to start, and I think I should do this a little bit. I think I should clarify in the sense that you can choose whichever way of learning that you like. I guess, and you can present people with various options, right? But anyway, all right. So let's get back to it. German C. Okay, so modulus. All right, so this is good. So this gives us remainder, right? So this is kind of like if you do it gives you the remainder from a division. So that's good. So it'll probably spoil it for us there, right? You're correct if you concluded that the function of the modulus operator is to give the remainder of the first value divided by the second value. Indeed. And then you can use modular arithmetic, right? And that's huge in cryptography. It's a good meme. Yeah, I honestly, well, I don't know. I only speak English, unfortunately, so. Modular, my beloved. Yes. This is, if you want to get into cryptography, big deal. You're gonna be modulus is gonna be your best friend. Also, what was the other? Oh shit, that is not what I wanted to do. I jumped way the fuck ahead here. Hold on. What page were we on? We were here or something. Here, yeah, here we were. Okay, page 60. Deutsch.h. That's funny. So yeah, so we can do that example. So let's do that. So if we go back to our Vim, we'll do a modulo here. So the example, for the modulo, so if we did res is 25 modulus 2, of course this is going to be this is going to be 1, right? So 25 modulo 2, and we have to do double because it's a protected, the percent is protected, right? So that's going to be, this is going to be 1, right? Because 25 is an odd number. 25 modulus 2 is going to be 1. So there. Good. Can you whip up a manual modulo calculation? What do you mean? Like, I could. What? I don't know exactly what you mean by manual. Oh, like going through it, like on the notes. Oh, like calculate the modulo. Ooh, good example. Let's do that. That sounds like a fun puzzle. Do you want to do that? Let's do that. Maybe a function? Yeah. Well, you just do it as a program. I mean, we could do it as a function too. Yeah, actually, no, let's just do it as a function. That's a fun exercise. Okay, let's do it. So let's just do the function up here. Let's say, I mean, we can remove like some of this garbage here. We don't need all of these anymore. I know there's a way of like mass deleting lines, but I don't remember how to do all that, but that's okay. So I'll just leave it there. Okay. Whoops. So int modulo, and then we'll give it, just say void. Actually, no, we would return an int, no, wouldn't we? We return an integer. Or no, the return is from this. Sorry, this is the return right here. My bad. So we're gonna say int results. Shift V, move cursor to selection X. Got you, Hogan. Yeah, I'm still new to Vim too. You want to take an argument? Yeah, I guess I could. Yeah, I guess I could do that. So I could say int. You can say int n and d, right? So for numerator and denominator, right? So we'll do int res. Okay, so let's think about how to do this. Now, this is a good exercise. Yeah, right. 2 arguments. Yeah, exactly. So I gotta think about this because I actually don't know off the top of my head. So the idea is to implementation of modulus operation without operator. We'll just say that, like one does indeed. Because I feel like you'd have to do. I feel like there's a way of doing it with bit shifts, right? It would probably involve bit shifting. I just don't know how off the top of my head. Yeah, this one's actually tricky. I don't know. I just haven't thought of this. Bit twiddling only. Yeah, I know it involves bit shifts in some way, right? So so here's what we know. Okay, this is what we know. Okay, so we know that if we do, I think it's, oh, what? There's an AI window? I didn't even know that. I didn't even know that was a thing in iTerm. Okay, it doesn't matter. I'm using iTerm as my terminal emulator. Anyway, it doesn't matter. So what we know is we know that this, so if we do n shift left 1, then that is a left shift. Shift by 1 bit. Or b bits. Say. Okay. And then this is right shifting. All right. Oops, the AI open. That's how it starts. That's how you get hooks. Fair enough. I didn't know that was even a thing. I'm using iTerm, guys. Full transparency. $12.70. What do you mean? Okay. So, and a bit shift left. So, a 1 bit shift, one bit left, or 1 bit left is equal to divide by 2. Right? I think. Or is it bit shift? No, it's multiply. Sorry. Multiply. I think. And then 1 bit shift right is equal to divide by 2. Right? Oh, of the C manual. Oh, yeah. There's 1270. We're already on page 60, though, guys. Come on. What's that? Let's say we do... I mean, am I going to finish all of it? I don't fucking know. There's math formulas, by the way, once you learn how to do it the long way. Yeah, no, I bet there is. I bet there is, Hogan. Okay. So I think what we want to do is... Obviously, we need to figure out... Like, there's probably... I don't exactly... There's a way of doing it with bit shifts. I just don't... It's like bit shifts and adding or subtracting 1 or some shit like that, right? Bit shift will only work if it's a power of 2. Yeah, no, I know that. Right, so if you bit shift... So, like, for example, if you... 2 bit shifts left would be multiplied by 4. Right? So, et cetera, right? And then, et cetera, right? Same thing with division. Now, I think what we would need to do is we would need to go through the individual bits. Like, it depends on the denominator, right? So we're shifting based on the denominator. It must be. So I think, I mean, yeah, because this is an interesting problem. Because it'd be trivial if D is a power of 2, this is trivial, right? Because then you just, shift by, the logarithm. Log base 2 of D, you just bit shift, right? But then the trick is when you get numbers that aren't a power of 2, right? I'm also using a mouse to highlight in Vim. I know that's cursed. Don't come after me. Just to illustrate my point. But yeah, so, I mean... Let's think of a toy example. So obviously if we do 25 divided by 2, okay? So obviously if we do 25 divided by 2, or modulo 2, right? So we do 25 modulo 2, okay? So then we know 25 is 0, what would it be? Let me think, 1, so it's 16 plus 8 plus 1, 4, 2, 1. So this is 25 in binary, right? So it's 25 in binary. And then we know 2 in binary is 1, 0. So then if we shift right 1, then we get 1, 1, 0, 0, and then that 1 is cut off, right? And we know that that 1 gives us that is the remainder here. Right? So if we do 25 modulo 2 and then we bit shift right 1 and then we take what was bit shifted off, then that gives you your answer. Right? Does that make sense? So, and then this number, for what it's worth, here is 12. 8, 4, 2, 1. That's 12. So 12 remainder 1. Right? Now, if you're dividing by 1, it's trivial. You don't have to do anything. Obviously, right? So that's our modulo 2. So our modulo 2, and then this goes for any power of power of 2, right? So if we did 25 modulo 4, I also have caps on. That's not what I want. So that'd be 11001, 100, and then we bit shift 2, and then that would be 110, and then what would it be 01. So then we would have 6 remainder 1, which sounds right to me. Right? Because you know 24 divided by 4 is 6, and then remainder 1 because of the 25. So that's good. So that's fine. So now let's think of another example. So 25. So what happens now when 25, we have to 25 modulo 3. Okay, so this, we have 11001, 11. Okay. So then when we bit shift it, so let's think about what this would actually be. So 25 divided by 3, or, well, 25 divided by 3, 24 divided by 3 is 8. So then it would be 8 remainder 1, right? 7 modulo 3 is an easier example. Start small. I think this is small enough to get the point. I think this is small enough to get the point. But we could, you know what? Fair enough. Let's do 7 modulo 3. So 1, 1, 1, and then 1. 1, 1. Okay, so then we shift that. So let's shift it 1. Okay, and we get 1, 1, 1. And then, so what do we have to do? So 7 modulo 3. So 7 divided by 3 is, would be 2 remainder 1, right? So the remainder would be 1. So you're just shifting 1. But then I don't know what you actually do past this. Because 7 modulo 2 is 3 remainder. Or sorry, this is 3 remainder 1. Sorry, this is 3 remainder 1. So this is 3. And then this is 1. So the remainder is right, but then what do we do? Oh, then you subtract 1, maybe. Do you subtract 1 from this part? Maybe you subtract 1 from this part. So if you subtract 1 from the what would that be called? Left side. Then that would be 1, 0, 1, which is what we want. And there's our final thing. All right, so we have 2 remainder 1. 1, 0, 1. Like that. I don't know if anyone's following this. So let's go back to our 25 example. 25 remain modulo 3. So 1, 1, 0, 0, 1, 1, 1. So let's try that same example. So we want 8. So then we'll start by shifting by 1. There isn't a one size fits all. No, that's fair. That's fair. Maybe there isn't. And we'll maybe find that out the hard way. So if we shift 1, then that's 1, 1, 0, 0, 1. And then we're left with, and then so let's do our same -1 strategy. Then that would be what, 1, 0, 1, 1. Oh yeah, that doesn't work, does it? Because that's not 8, right? Ah, yeah. Okay, so that's interesting. Or sorry, no. That's not. We would need to subtract. Yeah, so subtracting 1 there trivially doesn't work. If you go the math route, it'll be much easier and work for every number. That's fair. So there is a way then. Looking at how to do this, there's no trivial way. Yeah, no, that's fair. I got you, Jericho. Just a second. But yeah, no. Okay, so if we go math, 100% mathematically, it's trivial. Yeah, well, mathematically, obviously. It would be. Because you just basically find, C is so mathy. Well, not necessarily, but this particular part that we're focusing on is arithmetic, right? So it's actually, so much binary. Yeah, but that's how numbers are represented in the like at a low level, right, Obi? So Yeah, so obviously float division works as you'd expect, right? However, you will have precision issues. Yeah. C is very data oriented. Yeah. 12-year-old me would have thrown the family computer out the window. Yeah. Well, also, you at 12 versus you at however old you are, very different people, right? So, in fairness. Can you... Let's actually look this up. Modulo function with bitwise operators. I have no, shame in Googling this because I'm just curious. Mod of power to... Yeah, so you can mod of... drink less mod, that is fair. So we know, for example, yeah, so this is obvious, right? Yeah, so this is obvious. You can also do an and. That's true. But no, there might not be a trivial... X plus X divided by 7. Yeah, but see, then you're using this, right? Problem comes when it's not. Yeah, exactly, Hogan. Exactly. So you do... Oh, yeah, that actually makes sense. That actually makes sense, yeah, because mathematically, you would just add... the... the number, right? So if you did... I think it would just be... Yeah, as it said before. I mean, actually, no, let's leave that in there, actually. So I think this would just be... Yeah, because you have to add one. So it'd be n plus n divided by d. And then you and that with d. Right? Because d is the denominator. So then, or would it be d minus 1? No, it would just be d. I think... And then that just takes off the... Is that the answer? I don't know. I actually don't know. Actually, we can try it out, first of all. Let's say modulo. Let's just do also 25.2. So let's think about the 25.2 example. So that would be 25 plus 25 divided by 2, which is 25 plus 12 and 2. Yeah, you're getting closer. Okay. And if we and that with 1, 0, then that just gives us... I think it would still need to be d minus 1, though, wouldn't it? Would it be d minus 1? Is it a minus a divided by b times b or something? Spoilers. But yes. Oh, you're doing pure math. Okay, I see. Yeah. Okay, I see. 25 minus 12. So if we had... Or 25 minus 12 times 2 is 24. That doesn't give you the... But that doesn't give you the remainder, though. Does it? That just gives you the... Or does that give you the remainder? I don't think that gives you the remainder. No, good job, Obi. I'm also tired too. It's been a long day. I don't know. My analytical thinking is just fucked. So let's work through that example then. So like if we do like 25, I might be wrong. So 25 minus 25. Now here, are we assuming that this does an integer? So then times 2. So then that's what? So it's 25 minus 12 times 2. So it's 25 minus 24. Oh yeah, no, it does work. It does work. It does work. It does work. Yep. I see it now. Yep, you're right. Totally does. Yep. Exactly. Nope, you're totally right. I just can't think apparently today. So, and then it's this. So that's what it is. So it's not, sorry, n divided by d. Sorry. There we go. So that should work now. So then, whoops. So then we should get printf. So 25 modulo 2 is equal to, and the res, right? So that should actually be fine. And then we'll do that. Yep. Or wait, did I fucking, hold on. What did I do for the... this. I need the double. That's why. Oh, wait. There we go. Nice. Yeah. Okay, cool. That's why math rules. Math was my minor. Nice. I'm honestly not that good at math. I'm not going to lie to you. All right, let's take one more break. No, that's fair. I appreciate that, Hogan. That's I appreciate it. But no, that does make sense because you're if you subtract what you divided, if you like take the regular number and then you subtract, yeah, you have the rest. Yeah, that makes sense. Yep. Although I can't I can't formulate words today. What's my workflow and to code? It changes depending on what I'm doing. Why C and not C++? Because C came first, of course. And it's also less to learn. Basically, see how many times it fits in, subtract the rest. Exactly, yeah. No, for sure. And it's like when you haven't thought of this stuff for a long time, it's not trivial. Right? Like I mean it is when you think about it for a second, but I don't know, when you're trying to like do it off the dome. Yo, how's it going, Ree? But yeah, I don't know. Water Jug Riddle and Die Hard 3, which is basically math. Fair enough, Obi-Wan. I've never played that game. Yeah, maybe there is. I thought for sure there'd be a way, an algorithm to do bitwise or modulo arithmetic with bitwise shifts. Surely. I thought for sure there was a way, but I guess maybe not. I'm about to study math again and try to get to differential equations on my own this time. Nice, Hogan. That's awesome. Is it like to use to be before like Stack Overflow and documentation? Yeah, my math is my math is really rusted up. Yeah, it wasn't trivial for me either, Innovation. Don't worry, you're not alone. You're not alone. I haven't I literally offloaded all the discrete math I learned, dude. Like, and I haven't done like arithmetic shit in forever. But yeah, no, learn. That's kind of what I do. Yeah, like before AI. What was the first computer language? Wasn't the one invented by Turing? I mean, Turing didn't make a language, though. What Turing did is he defined, well, I guess it was kind of a language, but it wasn't really, discrete was interesting. Yeah, discrete was hard. I almost failed discrete. I'm not going to lie. I got like a C. Well, I guess C isn't really failing, but I did not do well in discrete math. Am I going right back and forth between the CRUD app and learning C? Yeah, exactly. Just to vary it up, Re. That's exactly what it is. That's a good exercise. That was innovation. But no, Turing invented what's called the Turing machine, which is essentially a description of a computer, almost like an abstract computer that can interpret a program with like the infinite tape of binary, and then it has rules for shifting the read head back and forth and moving things on and off the stack. I forget exactly what the definition of a Turing machine is, but it's something like that. Not an analog computer, just I mean, we could go into that side quest if you want. I actually forget the exact definition of a Turing machine now that I think about it. Love taking class where we learned about those. Yeah, exactly. Yeah. Ben can explain. You got it. Yeah, Hogan, you can take the reins on that one if you want. But I want to remind myself about the Turing machine. Yeah, so essentially it's an infinite tape with a bunch of binary values, so zeros and ones, right? And then you have a read head, which basically, yeah, so it reads one symbol on the tape and moves the tape left and right one, and only one cell at a time. And then I think the instructions, there's a finite table of instructions that you can have that manipulate this data, right? So the instructions can either erase or write the symbol that's being pointed to. Yeah, as it says, it can move the head left or right or stay in the same place. And then, yeah, that's pretty much it. And then basically the idea is that, oh God, this is, oh no, not the 7 tuple. I remember this from my cellular automata class. This is like cursed. And then basically you can use this to define, you can define the set of, like you can use this to basically define what a Turing machine is. Oh God, I remember this. I remember this. I honestly can't. I'm not going to go into that, but am I still in uni or working in CS? I'm not in uni anymore. I was though. No, Turing was a genius. Turing was a genius. It did trigger PTSD. Well, all the dude, because like, so you have like, I'm not going to get into this. I'm not even going to fucking attempt to explain this right now. But essentially, this is like formal math for a Turing machine that you can use to define finite state machines of similar type. So basically, Q is the set of states, and then gamma, capital gamma, is the set of instructions, or no, symbols for the tape head, and then delta is the set of transformations, right? Something like this. Transformations between different states. So anyway, doesn't really matter. We're not going to get, we're going side tangent. Yeah, exactly. And when you're doing an integer division, Hogan, that A divided by B automatically does a floor. So like, for instance, in C, if like, let's just do this as an example. So I'm going to actually scroll this up. A divided by B, assuming, so if we have int A and int B, okay, A divided by B is the equivalent of floor A divided by B or C divided by D, and then let's say that C and D are floats, right? Well, actually, then you'd have to convert it, but essentially that's the integer divisions is that. It's kind of like a floor function of the result, right? You're just taking the decimal off. Anyway, but that's kind of what Hogan was getting at, I think. So, Yeah, no, that's the largest multiple of b under a, assuming that a divided by b does give you that rounded down. Yeah, so you've basically got like, yeah. Division truncates any decimal point. Yeah, exactly. So it's like that a divided by b times b gives you the largest value smaller than a, such that, or like the number of times a fits into b cleanly. Exactly. I don't have many opinions on Rust. I haven't started learning Rust. But you can talk to Innovation in chat. He knows about Rust. Is it worth the hype? I don't know. It might be. I'm going to say a strong maybe on whether Rust is worth the hype. Maybe, probably, yes. But I'm not going to say, I can't say for sure. All right, let's get back into the textbook here, guys. I'm glad folks are having fun in this stream. It seems like it's being well received. The multiplication innovation. So like, let me actually, do you want me to walk through an example? Here, I'll walk through the example. So we have 25. So let's say int a is equal to 25. Int b is equal to 2. Okay. So then we have 25, or we have a divided by b is equal to 12, right? So then, and that's because it would be 12.5, but we truncate it, right? And then when we times that by b, we're getting 12 times 2, which is equal to 24, which is the lowest or highest number less than a that can divide b evenly, i.e. without remainder. So then to get the remainder, we take a and then subtract it by this, right? Does that make sense? Maybe? That's kind of that. Yeah. So then that effectively is 25 minus 24, which is equal to 1. No, you're good, Hogan. Yeah, you're good. No worries, Innovation. Why is it not rounded up to 13? Because whenever you do integer division in C, it always takes off the decimal point. So a divided by b is 12.5, right? But C, because of the way it works, it ignores the decimal point. So it's always a floor operation, Milo. If that makes sense. They cut off, exactly. Rust streams in 2027, guys, okay? Actually, no, 10K subs. If we hit 10K subs, I'll do Rust. How's that? If we ever hit 10K subs, I don't know if we will. But there's some incentive. It could be 12.9. Yeah, exactly. There's no rounding. Milo. It's just a floor. AKA Ben saying he doesn't want to do it. Not yet. I think Rust is good. I'm just intimidated by it, right? All right. So then we went through all this remainder ad nauseum, so we can kind of skim through this, right? So last line of the output. Okay, that's fine. So then what is the precedence of modulo? Okay, so modulo has the same precedence as... okay, so modulo operator gives remainder and has the same precedence as multiplication and division. Right? Good. So it should be, we should get that from, where is it? Yeah, there's no coincidence that the value is the same as the value of the value. Okay, let's see. Does it actually tell us where the precedence is? Modulus operator is equal precedence. Yeah, that's what we want to. That's what we want to highlight. Right there. Good. All right, integer and floating point conversions. Okay, so let's do that. So int and float conversions. You must understand the rules that are used for implicit conversion of floating point and integer values. Program 3.5 demonstrates some of the simple conversions between numeric data types. You should note that some compilers might give warning messages because you're not explicitly casting, right? So, I mean, for sake of example, we could do we could write this out if you'd like. I would like to raise to you Kotlin is the best functional language that isn't a functional language. That's fair. I've heard Kotlin's very Java-like, Hogan. So all right, let's make a new program. So we'll say vim number conversions or number conv dot .c. Okay. So my keyboard wouldn't double type. Okay, so we have float f1 is equal to, let's do 456.78 to be fun. 789. Actually, I mean that's a bad example. Let's do one. Let's actually do 0.625. And then f2. And then we'll do int. Actually, we can go back one, right? Okay, we'll do an int I1, I2 is equal to negative 150. We'll do negative 250 to be different. Yeah, and then we'll do char. I guess are we doing characters now? Okay. What IE am I using? I'm using Vim. Welcome to the rabbit hole. Yes, SVN. Yep. I'm using it because it's nice to just quickly do with C, right? Okay, so float to integer. So if we do I1 is equal to F1, and then we print F, at I assigned to a float produces float. I2 or F1, sorry, F1. Sorry, this is the wrong way. I'm reading the wrong thing. F assigned to an int produces this. Right? Then we can do F1 is equal to I2. We'll say I assigned to a float produces the float. So let's see what that does. And I don't mean to press double colon there, by the way. It's just my keyboard has a bounce issue. My Obi tokens have ran out. Damn, Obi. It's 2:30 a.m. I head off, but I appreciate you being here, Obi. Good luck. Appreciate you, Adam. But no, I think, yeah. I think Obi, is Obi in the Discord? I don't know. Anyway, let's compile this. So 456.65 assigned to an int produces 456. So that just truncates, right? However, if we made this now, if we gave this a big int, if we gave this like a 9, like if we made this 456.999, that should be 456. It doesn't round, as far as I know. Yeah, see? So you can see here that 456.998, well, there's precision problems, but that's fine. Assigned to an int produces 456, and then negative 250 assigned to a float produces negative 250.000. That gives it the right precision. Cool. Now we're like dabbling into typecasting, I think. Right? Float rounding can be weird, yeah. It definitely can be. But yeah, so if I go to Vim, okay, so let's write some more statements here. So if we go like f1 is equal to I2 divided by 100 as an integer. So this is an int division. So this will be, you know, at I assigned or divided by 100 int produces at f. So then that is I2 f1. So then now I2 is 250 divided by 100 is negative 2. So this would be negative 2.0000, right? See? There you go. Now, I would assume that if we do this instead, and I think you can actually annotate float with f, right? Can you do that? Or does it have to be 0? Like I think this is a thing, no? Float. Ah, so you can't do that. Okay. I thought there was a way of doing that. Okay, done on Discord now. Adios. See you later, Obi-Wan. Thanks for coming. Or does this have to be define float numbers in C? I could have sworn there was a way of adding an F to the end. Unless I'm tripping. Oh, maybe you need the dot. You need the period. You need the decimal. Whoops. Like this. That's it. That'll be a float now. I don't even think you actually need the F at the end, in fairness. Okay, so see, now 250, negative 250 divided by 100 as a float produces negative 2.5. But when you divide it by an int, it truncates it. So, you know, it divides by 100, but then that produces 2.5. But then obviously the decimal gets cut off. So that's a perfect representation of that here. And we could even make this, to really drive home the point, we could make, instead of negative 250, we could make this 299 and the same thing would happen. Right? So yeah, now you can see that, let me actually rerun that and bring this up to the top. So you can see that negative 299 divided by 100 float produces negative 2.99. Negative 299 divided by 100 as an integer still produces negative 2, right? So that's kind of that chunking off behavior shown, I guess. In the sense that the decimal for integer divisions just gets cut off no matter how big it is. All right? So that's good. So it's like a floor operation. So good. Good demo? Yeah. Thank you. I appreciate that. And then now the last thing is we can cast. So if we take the division I2 divided by 100. So this is our int division. So int division casted to float and then assigned to float, right? So we can cast it by doing the bracket float like this, right? Advice for people who procrastinate. Honestly, find a way to hold yourself accountable. And I've said this before. Find a way to hold yourself accountable and to want to show up. Like for me, it's wanting to stream for you guys. That's what prevents me from procrastinating. Here's a question. What is the range of whole numbers a float can represent? Okay, good question. I think that's dependent on the exponent, right? So let me work through an example after I type this out. So if we go I divided by 100 int casted to float produces. And then so does this cast work? I actually don't know. Well, I guess we'll find out. It does. Okay, so the cast does work in the way you expect it to. So nice. That's very cool. I don't think the last one is int division. The cast happens on I2. Does it? Oh, but does it happen on both? Because if we go back here, I thought it casted the whole result. Because this 100 is also an integer. Right? So I actually don't know that what's true about that. Because this is the int division here. If it was int division, then casted, the result would be 0. Yeah, maybe you're right. I don't know. But this is also, does it cast each individual one? Like, because this is an integer. This 100 is an integer. Right? Okay, so like if we did, let's try that out. So let's try bracketing. Let's just cast the I2. Denominator doesn't matter. Interesting. So if we did this, then does that still work? It does. Okay, Mon, you might be onto something, my friend. Maybe you're right. That's fair enough. So that actually did not change the behavior. Okay, fair enough. So it does cast. So let's actually rewrite this. So cast I2 to float, divide, and then assign by float. Or assign to float, I should say. So, and I would assume that gets described if you did float I2 divided by 100. Okay, let's try that out. Let's try that out. Nah. It just produces 2. Produces -2 because you're doing the integer division first. You're bracketing out the integer division, and then you're casting, right? So when you do the integer division, you get 2, -2, I should say. And then you're casting to float, right? So that actually makes sense. That actually makes sense. Is I2 less than 100? I2 is -299. So that's -299 divided by 100. So that actually makes sense. What do you think of Java for backend development? I've never really tried it, but I know it's a legit crisp. I know people use it. But that actually makes sense because you're doing the integer division first, and then you're casting to float. And then once it's already, so the int that you get back is -2, and then you're casting that -2 to a float. Yeah, which is exactly what it does. You're right. You're right. So cool. All right, so let's do a little bit more reading here. So when a floating point value is assigned to an integer, the decimal portion of the number gets truncated. Yes, we've been through this, so it's fine. So when the value is assigned to I1, blah, blah, blah. Okay, we kind of like jumped ahead a little bit here. Yo, how's it going, Afner? The int gets casted to float. Yeah, that's true. That could be true. Innovation. And assigning an integer variable to a floating variable does not cause any change in the value of the number. The value is simply converted by the system and stored as a floating variable, right? The second line of the program's output verifies the value of I2 is correctly converted and stored. Yes. Which is why you have that decimal 000 here, right? The next 2 lines of the program's output illustrate 2 points that must be remembered when forming arithmetic expressions. So when 2 operands in expression are integers, The operation is carried out under the rules of integer arithmetic. Aha. Okay, so here's our answer, I think. So if we go a little bit further ahead, then the next division performed in the previous listing involves an integer variable and a floating point. Any operation between two values in C that are performed as a floating point operation if either value is a floating point variable is or constant. So essentially, we get, I don't know why I highlighted this. I don't want that. There, okay. But that makes sense. Looks like you're using Vim. Yes, I am. I'm using Vim for programming in C. So this is good. Any operation between two values in C that is performed as a floating point operation if either value is a floating point variable or constant, or is performed as a floating point operation. So essentially that answers our question earlier, Mon, which we kind of already came to, before. So therefore, when the value of I2 is divided by 100, the system treats the division as a floating point division. Right. What happened to WebDev? It's coming back. It's coming back. We're just varying up the content. I love C programming. Nice. Yeah. We're just switching it up a little bit. We're not the web dev's coming back. Don't worry. We're gonna do a web dev stream either tomorrow or Wednesday. It's scheduled for Wednesday right now, but I don't know when I'm gonna do it. How's this book for C? I use K&R to learn it. I've never heard of Kochan. Yeah, the reason I use this one is because it's newer, primarily. It's because it's a newer book. It was released, I think 2015, 2014 or 2015. And I know, it's like, the other one you could still use, but I don't know. I wanted to be different, I guess, primarily. And I did a cursory glance at this book, and it seemed reasonable. So, but I like it. Okay, so the typecast operator. The typecast operator has the effect of converting the value of the variable I2 to type float. So this is exactly what we were kind of running into before, right? And then because it's a float, then the division was treated as a floating point division, right? Because I2 is casted. So we cast I2, and then because I2 then turns into a float, then we treat the whole thing as a float division. And then assign it to a float, right? So, yes. So that's good. We're almost at the exercises, guys. So I think we can actually get to the exercises by the next stream. So let's go through this last little section. So the exercises are right here. So we're just gonna finish this combining operators with assignment. So let's just do that now. Or operations. Okay. So the C language permits you to join the arithmetic operators with the assignment operator using the following general format: OP equals. Okay. So in this format, operator OP is any of the arithmetic operators, including plus, minus, multiply, divide, and modulo. In addition, op can be any of the bit operators for shifting and masking, which we haven't gotten to yet. So count plus equals 10. So this is kind of explaining, why the plus equals exists, right? So basically allows assignment to be combined with operations like plus, minus, times, divide, modulo, right? In the same line, I guess, right? So then we say like C plus equals 10 is equivalent to C equals C plus 10, right? Something like this, right? So that's pretty trivial. Slightly more involved example is A divided by equals B plus C, which divides A by whatever that appears to the right of the equal sign, by the sum of B and C. So the addition is performed first because the addition operator has higher precedence than the assignment operator. So that's the other thing, is the assignment operators have lower precedence than non-assignment operators. So even if we did, so for example, if we did, let's say C plus equals A minus B, then this is equivalent to, no, we're just going to add our semicolon. We'll say C equals C plus and then A minus B. Or you could even do it as, you know, like so that like this, right? So that's the equivalent. Do we use Vim inside of Obsidian? No, absolutely not. No. I have a terminal that I have minimized. I'm using it inside of a terminal, crisp. Anyway, so that's cool. The motivation for using assignment operators is threefold. First, the program statement becomes easier to write. Okay, so it's motivations. So one is easier to write. Slash, or let's say reasons. What would I call this? Like use cases or reason for use. Easier to write. Easier to write, easier to read. Allows for programs that execute faster. Because the compiler can use this assignment or operation assignment. Operation assignment. Arrow is C syntax. That's why I did 2 dashes. That's why I did 2 dashes here. To specify that it's not, it shouldn't be considered as C syntax. I'll even do it like with equals signs. Just to specify that it's just an arrow. I'm using it semantically as an arrow. I'm not using it to actually represent anything. Yeah, so because our compiler can use this operation assignment to optimize and generate less code. Okay, something like this. Okay, so types complex and imaginary. Before leaving this chapter, it's worthy to note of 2 other types in language called complex and imaginary for working with complex and imaginary numbers. So that's fine. So actually, we didn't even write anything for that. I'll probably just include that here. Complex and imaginary for working with complex / imaginary numbers. So support for complex imaginary types have been a part of ANSI since C99, although C11 does make it optional. The best way to know if your compiler supports these types is to examine the summary of data types. Very cool. All right, so I don't think it really gets into the usage of complex and imaginary, but they're there. So if you want to do any fun stuff like that, there's C syntax. I think the reasoning for that. Okay, so let me jump ahead a little bit. So like let me just show you an example. I think that is for isn't the arrow in syntax for accessing parts of a struct? So like if you have a struct, I don't actually remember how to define a struct. Is it like struct int? And then my struct. And then like I forget exactly how to define it, but it's like, and then you like define the different fields, right? Accessing struct if struct pointer. Yeah, something like that. I if I remember correctly. I don't remember exactly how it works, but yeah, it's something like that. Right, okay, I see. Innovation. Yeah, thanks for the clarification. Yeah, no, again, these arrows here are semantic. They're not meant to be syntactic. So anyway, semantic for just illustrating this. Anyway, that's typedef struct. Oh, it's typedef struct name. Okay, I see. I appreciate that. I honestly did not remember. Cool. Cool. Anyway, I think that's going to do it for this initial C stream. You want the typedef to not need to write struct every time you declare. Yeah, that's true. Right, because then you create a type based on that struct, right? so that the compiler understands the struct as its own type. The arrow is used to access a struct field through a pointer. Yeah. Okay, thanks, Afner. Anyway, so I think that's going to do it for this stream. So I appreciate each and every one of you coming. In the next C stream, we're going to be digging into the Chapter 3 exercises. So we're going to do that, and then we're going to get into Chapter 4, which is program looping. Fantastic. So anyway, with that being said, if you want to follow along with my journey with web dev and C, and other endeavors that I decide to do in the future, then feel free to subscribe. And also feel free to join the Discord, where you can chat to over 400 of my community members, our community, about anything related to programming or what have you. And yeah, so I'll see you guys next time. I'll be live either tomorrow or Wednesday. If you want stream updates, join the Discord, and I'll see you soon. So see you